Let's get a microphone. Sound is good. Sound is gooder. How are we doing, everyone? Can you hear me? Can you see me? Are we ready to do a little bit of mathematics? Pop a little hi, pop a little ho in the chat so I know we're all good. Pranav, you're supposed to be in bio, are you not? No biology for you. Hey, Dangerous Dan, we got Danger Dan in the chat. Oh, I'm going to take a whoops. Mudassir, Shah. I might need help pronouncing the names, which in chat form is not as easy as you might think. Mubsi, hey, how we doing? We got people logging on. Hopefully we're all here to do a little bit of further math this evening, see what Easter revision. Okay, cool. I'll go with that Mudassir then, I think, is what I went for, but... Hey, Artin, you're in year 12. Is Demoivre's that hard? Not really. I don't think so. But, you know, everything's subjective. Really, it's probably a use of complex numbers that you haven't looked into yet. But I'll try and give us a good overview, go through a few questions, give you a bit of an idea of what's going on. Who else have we got this evening? Evening, afternoon, 5:47. Is that evening or afternoon at this point? Who knows? Who knows? Shall we just get cracking on? Let's just get cracking on. You got some pen and paper to go along with us. So when we go through a full session, you will have workbooks available to print out and follow along with at home. This session, because it's a little bit more ad hoc, we haven't done that. So get some paper ready to follow along with us. But on the full Easter revision course, you have waiting for you full PDFs of everything that we're going to go through. So you've got all the questions ready to work along with at home. Okay. Oh, first of all, a lot of you probably do not know me. Who am I? I am Nick Featherstone. Oh, we got with Nicholas on this one. I do prefer Nick. So there we go. You might have seen me on Nick Does Maths. Pumping out all sorts of interesting further math stuff and occasionally even getting it correct. I've been a teacher for 13, 14 years probably now at this point. I've been teaching all throughout since university, got myself a 2-1 from Oxford for my sins with a master's degree in mathematics. So really I've dedicated an awful lot of time and my life to the study of maths. I kind of enjoy it. So yeah, that's a little bit about me, and now I'm with Headspace, helping out Neil. Helping Neil out, the big man. So, what is De Moivre's theorem? What is De Moivre's theorem? Well, let's just start with the just overall statement of what De Moivre's theorem says for us. Really what it boils down to is this. If I have a complex number, cos theta plus I sine theta, and raise that to the power of n, you end up with cos n theta plus I sine n theta. All right, that's by and large what it means. All right, so for example, if I had cos theta plus I sine theta cubed, that is the same as cos 3 theta plus I sine 3 theta. Now, where does it come from? So where it comes from, you might have seen this result in your lessons or not. But you can prove this using multiple angle formulae. So arg of WZ is the argument of W plus the argument of Z, if we're thinking about things in modulus argument form. So this really is the core of De Moivre's, and this is our basic of the theorem. All right. Now, cos theta plus I sine theta. All right. Now, the other way to think about this is, of course, you might have seen the exponential form of a complex number. So cos theta plus I sine theta is e to the I theta. And the rules of exponentials tell me that e to the I theta to the power of n is e to the I n theta. So really it's telling us the same thing, but all of that comes together really, really nicely from multiple points of view. So I quite like it. I think it's a very elegant bit of maths, and there's all kinds of applications to it. Now, when we use de Moivre's, it's largely to do with trig. We do like it for trig, but we can do it all kinds of stuff. But we are going to use it to do with trig. So this evening, I want to look at this in the realm of trigonometry rather than roots or anything like that. So there are two real ways to look at this. Okay. So number one is this statement up here. Number one is this statement up here, which you can't see. I keep thinking I've got a laser pointer. So this statement up here is one of our ways of thinking about it. Another really nice way of looking at things is this. Now, if z is cos theta plus I sine theta, z to the power of -1, all right, so we're using n is -1, that is cos of minus theta plus I sine of minus theta. But if we use what we know about cos and sine graphs, cos of negative theta is cos theta, and sine of negative theta is negative sine of theta. But what this becomes really, really interesting is that if I add these two things, z plus z minus 1, I will get 2 cos theta. And if I subtract them, z minus z minus 1 is 2i sine theta. Okay? Are you with me? So this is our general theoretical background of the ways we can roughly use de Moivre's theorem. Are we all good? Give me a hi, give me a ho, give me a thumbs up. So I know that we're still with me. Got one of you. Awesome. Mubsy. Wicked. So let's do an actual question using this. I've got 2 questions lined up for you. Let's see what we can do with them. But all of this on this page is my little idea of what de Moivre's really means and how we can use it. So we're going to show that sine 5 theta is 16 sine to the 5 theta, yada, 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 yada. All right. How do we go about this? Now, this type of question, we want sine 5 theta. So we are going to use the fact that cos theta plus I sine theta to the power of 5 is equal to cos 5 theta plus I sine of 5 theta. I'm aware my s's and my 5's look very, very similar. Leave me alone. Okay, so what are we going to do? We are going to actually do the binomial expansion of cos theta plus I sine theta. All right? So let's do this. Because we as well good at binomial expansions, aren't we? So what do we get? We'll get cos to the 5 theta plus 5 cos to the power of 4 theta, 5 I sine theta, 1, 5, 10 cos cubed theta sine squared theta, another 10 minus 10i cos squared theta sine cubed theta. Oh, we're running out of page. I think we're back to plus 5 cos theta sine to the 4 theta, and then plus I sine to the 5 theta. So all I've done here is the binomial expansion. I've done my binomial expansion. You'll pick up multiples of i's, which is why you've got these alternating signs. Now, where is my identity going to come from, cool kids? Assuming all imaginary bits cancel out most of the time. What do you mean? You mean the i's and I squares? Well, really what we've got here, right, is because when we take powers of sine, right, we're actually taking powers of I sine theta. So here there's implied that minus comes from an I squared. Here I've got an I cubed. Here I've got an I to the 4. Here I've got an I to the 5. So we're going to use a lot of stuff that you've put in there. So Radomir, yes, we're going to use cos squared plus sine squared as 1. We're just going to slam an im in here. Yes, we are. So we are going to say, and this is our classic complex number move, right? Our classic complex number, which I find amazing. We go, hey guys, let's just chill and pretend that square root minus 1 exists. And you go, all right, it exists. And you go, but it doesn't. So all the stuff that's real is equal and all the stuff that's imaginary is equal. So the imaginary part, sine 5 theta, is equal to the imaginary part of my expansion. So the first step that I have is that, that sine 5 theta is equal to 5 cos to the 4 theta sine theta minus 10 cos squared theta sine cubed theta plus sine to the power 5 of theta. So all of our imaginary parts are the same. Now, funnily enough, we could get a similar expression for cos 5 theta by looking at the real parts, but that's not what we are looking at this evening. And this is where Radomir's insight comes in. I only want sine thetas, so cos to the 4 theta, that is 1 minus sine squared theta squared. Cos squared theta is 1 minus sine squared theta. All right. And this is how we're going to get our way. So 1 minus sine squared squared is 1 minus 2 sine squared theta plus sine to the 4 theta. And there's another sine theta still. You don't get lost, everyone. Okay. Now we just need to tidy it up. So how many, let's expand it. I'll never get it right first time if I don't fully expand it. Hot tip for you guys. Don't try and show off and do stuff all in your head. Just take the extra, maybe 30 seconds, it takes to expand everything out. Bosh. Bosh. And then if we collect our terms, I've got 5 sine to the 5. That should be sine to the 5, not sine to the 4. There we go. 5, 15, 16 sine to the power of 5. Minus 10 minus 20 sine cubed theta plus 5 sine theta. So this is one of our standard ways of getting sine 5 theta. You could do the same thing for sine 6 theta, cos 10 theta. It just becomes ridiculous doing the binomial expansion. But you can get these identities. You can get these identities, and it's kind of cool. And we can really start playing around. Now, why might this be useful? Well, it can be useful. So that was part 1. It can be useful for something like part 2. Let's solve this equation. Now, what substitution might we do to solve that equation? Who can see what we might want to do? How do these two things link? What substitution might I make if you look at this? I do apologize. Something's gone a little bit wrong here. Hang on, gang. I typed this up earlier and something went a little bit awry when I typed this up. Is my minus 20 correct? Is my minus 20 correct? I do believe it is. I'm out by a factor of 2 in both of these. I do apologize, gang. I just typed up the question wrong. It's a question that I came up with in my own little head, and then I typed it up wrong. So it should be 20 sine cubed and 40x cubed. All right, so we're going to make the substitution x equals sine theta. Now, if we make the substitution x equals sine theta, all right, if I make the substitution x equals sine theta, then you will notice something down here. I have doubled all of the coefficients, so my equation becomes 2 sine of 5 theta is equal to 1. All right, 2 sine of 5 theta is equal to 1, which tells me that sine of 5 theta is a half, which tells me that which tells me that 5 theta, come on eraser, why is this booging? Why is this booging? That's weird. So we end up with 2 sine 5 theta is 1, which is sine of 5 theta is a half, which is 5 theta is pi over 6. Now we've got pi over 6. Now we need to pick up all of them. We need to pick up all of our solutions. So what's my secondary solution? Pi over 30. Now I can also start adding 2 pi's to this. I can also start adding 2 pi's to this. So I could get 13 pi over 6. I could get... Sorry, gang. Right. So first of all, why does my eraser hate me? Why does my eraser hate me? Right, let's just pick up our solutions and we'll just come back to this side here. So we got pi over 6, we can add 2 pi, which is a 12 pi over 6. We can add another 2 pi, which is 25 pi over 6. Let's divide this by 5 as we go. So theta is 13 pi over 30. We've got theta is 25 pi over 30. Which solutions have I forgotten? I can tell you that I am missing some solutions here. Can you tell me which ones? Why is that not working? That is very annoying. Yes, we are missing the 5 pi over 6 as well. Thank you, Mubsy. We are missing the 5 pi over 6. And we can add 2 pi to that as well. So let's add another 12 pi. Actually, let's go as we go. 5 pi over 30. We can add another 12 pi over 6 to that to get 17 pi over 6. Add another, so that's 17 pi over 30. And should we go all the way up to 29 pi over 6? And we have probably gone all the way around here. Now, actually, I don't need the 29 pi over 6. Why is that? How many, because I could keep going on, right? I could keep going on forever. But how many values of x should there be? If we have a look at our equation up here, what kind of equation is it? It's a pair of 5, which I think is a quintic. So I should have 5 solutions. Now, so y is 29 pi over 30. Now, 29 pi over 30 is a perfectly valid solution to sine 5 theta equals a half. But why is it not a good solution for me? Or why is it useless? Well, because x is sine theta. Let's see if the highlighter works. Tell me something about pi over 30 and 29 pi over 30. Well, it's not just because it's a 6 value. What will happen when I take sine of those two values? What will happen now when I take the sine of those two values? They'll be equal, all right? Sine of pi over 30 and sine of 29 pi over 30 are the same because they add to pi, okay? So we'll take sine of pi over 30. Now, can you see another issue here that's going to happen? So we need to be careful. Oh, no, that is that is the bad. What? I apologize, gang. I've just had a perfectly good 1 hour lesson with my GCSE foundation revision, and it worked absolutely fine. And it's decided to absolutely destroy me. Now, 13 pi over 6. Let's quickly regenerate these. 25 pi over 6. I'm going to add a few extra ones in here. 37 pi over 6. 49 pi over 6. Let's see. We'll see later if I need to go to any other ones. 5 pi over 6. 17 pi over 6. Just when you're trying to meet new people is when the technology says no, thank you. Right. That is just 5 pi over 30, 17 pi over 30, 29 pi over 30, 41 pi over 30. And let's see where we go with this. So we said that pi over 30 and 29 pi over 30 are... Yeah, I have no idea why it did that. I'm a little bit annoyed. So, for example, 13 pi over 30 and 17 pi over 30 will give me the same value of sine theta. We've got 25 pi over 30, and I'm not even going to try and erase this because it's just going to drive me nuts. All right, so which values do I want? So x is sine of pi over 30 as an option. Sine of 13 pi over 30 as an option. Sine of 25 pi over 30 as an option. Right, 37 pi over 30 is an option because that doesn't have the same value as any of the other ones. And 49 pi over 30 is an option, although 41 pi over 30 would work as well. All right, and 1, 2, 3, 4, 5. What you will realize is any of these other ones, values you pick up of 30, they will give you the same sine value, and therefore it's the same value of x. So we should end up with 1, 2, 3, 4, 5 distinct solutions for x. Okay? So that's our general idea here. That's our general idea. Sorry. Few technical errors there. Not sure why. Computer decided after a perfectly good hour stream that chatting to further math students was too much for it and it was going to embarrass me. I do apologize for that. All right. So that is one application of demoiselles. I was hoping to get us through another one, but we're sort of running low on time this evening. But here we go. Right. Just pop a plus in the chat if you want a special offer. All right. because that is what my Headspace is doing for this Easter. We are running a special on these revision courses. Okay, I don't know if you've already signed up or not, but please do consider it. What have we got coming up? What do we have coming up? Well, we do have less technical errors. We do have less technical errors. What are we going to do? So on the Easter revision courses, it will be 2 days for further maths. 2 days. So we've got a 3-hour session in the morning, 3-hour session in the afternoon. All right. Open to extending that a little bit if we need to, right? It's not absolutely far. Like if we need to do an extra little bit in the morning, a little bit extra in the afternoon, we can. The plan will be to go through every single topic that is in the spec. Now, I will not necessarily be going through in this level of detail. All right. We will not have time to go through a full, 10-mark exam question for every single topic. That is like impossible. That is impossible. But what we will do is I will give you smaller examples for every single subtopic. All right, so there will be smaller examples for every single subtopic to allow you to make sure that you have checked everything and that you are secure on everything that is in the further maths. Here it says 3 6-hour revision sessions for further maths. We are doing it in 2 lots of 6 hours, so 12 hours. They are all recorded, so you can go back and watch them in your leisure. It will be quite fast. You will also have the full PDF of the workbook, so you've got all the questions to work along with. And I will be providing 3 mock exam papers, all right? So we are basing this largely off the Edexcel Further Maths for the Core Pure. That is identical across all the exam boards, apart from 1 or 2 minor changes. And then Further Mech 1, Further Stats 1. Now there's probably a few more differences between exam boards, but if you're doing any level of mechanics or stats in any of Edexcel, AQA, OCR, or MEI for further maths, there will you will cover stuff there that you will need to know. All right, almost no exception. With those, you will get they will be put up as a test that you can take along with fully worked video solutions by yours truly. Okay, with no typos, no hiccups, anything like that. That will all be ironed out. And tips as we go through it. So the idea is really we will go through in those 6-hour sessions a sort of much more overview of every single thing you need to do with the theory and a couple of examples. And then, as well as that, you will have those exam papers to help consolidate in more detail with fully worked exam questions. As well as that, you've got pretty much all the videos that I am posting on Nick Does Maths, either YouTube or TikTok, will give you great examples of ways that we are applying the knowledge that we will be going through in the Easter revision course. This is outrageous. I'm not on this slide yet. I'm new to this year. Look at that, look at that, look at that handsome chap there. All right, and what we found is this format gives really, really good results. We have found that the students that go on these courses go on to make massive improvements. Also, just in terms of confidence, you will find that it will help boost your confidence as well, going, all right, I know all of these things, and now I've got a much better understanding of all the other bits that are knocking about. All right. There should be a link in the video description for this evening so you can sign up for this, but please do. We just get to hang out, right? You can come. It's on Sunday the 6th, so this Sunday and then the Sunday after. 3 hours in the morning, 3 hours in the afternoon. We'll split it. This weekend, we've got some core pure in the morning. We're going to go through all the complex numbers and a few other bits, and the stats in the afternoon. Then the Sunday after, we'll finish off the core pure and we'll go through the mechanics. But we just get to hang out, nice relaxed environment, and just chat about maths for 6 hours for only 20 quid. Artin, will you still benefit? I think so, yes, because it's a full coverage, right? So it's full coverage, so I will be covering the AS material as well. So are you a year 13 AS student? So are you year 13 taking AS further maths, or are you saying AS student as in you're in year 12? I think you popped something at the beginning in the chat, but You're in year 12, right? So you'll be doing all the other topics next year. Is that correct? Right, gotcha. Yeah, yeah. Still, I think it's worth it. Absolutely, you've got your own exams at the end of this year. Now, there are some things that aren't decoupled as well between year 12 and year 13, but it's all good maths. The mechanics and the stats, though, on the other hand, you will easily identify that stuff I've done this year, that stuff I've already studied, and you'll be able to extrapolate. Perfect. You do further stats 1 and further mech 1, so there'll be loads in there. We went for further stats and further mech 1 because they are the most popular entries for EdXL by far. Yeah, so questions in the chat. Does anyone else want to ask anything? Hopefully this evening gave you a bit of a taster. Like I say, how different is the course from AQA? So Andrew, the core pure is identical. I went through and I did a course comparison. Let me bring this up on my other page. I think I can give you a little bit more if I actually have this open. In the meantime, so further mech 2, further stats 2, unfortunately we can't actually do everything, right? It would take days and days and days to cover all the different options possible. So this year we are only doing further mech 1 and further stats 1, but it will still help you massively. It will still help you massively. Oh, that's IGCSE spec comparison. Sorry. Numair, you did further pure 1, further pure 2, and no applied. I mean, there is some stonking great stuff in further pure 1 and further pure 2. Some really, really cool stuff. But yeah, it is something else. It is something else. So yeah, unfortunately, no further pure decision, but I do have a whole bunch of further pure over on the old YouTubes. So what do we go through? For example, we're looking at AQA. So the core pure is identical. Yeah, the spec is the same for core pure. For example, for AQA. For the stats, I think there's like small deviations, but we go through all the discrete random variables, binomial, Poisson, geometric, negative binomial. We do some extra hypothesis testing on discrete distributions like Poisson and geometric. We go through some central limit theorems, chi-squared tests. So where it gets a little bit more different, I think, is we will look at types of errors, quality of tests, probability generating functions. But the further stats one doesn't have a lot on t distributions, for example. So no t distributions. All right. If there is big demand for it, we can look at trying to run the cram sessions for those exams rather than the East revision. So 4 hours the day before. But for East revision, we just don't have the time slots to cover everything, I'm afraid. But core pure is identical for everyone. Further stats one, further mech one. There's a ton there for any exam board. Thank you, Mohammed. I appreciate it. Mudassir, I can't remember. You told me. I do apologize. Are you doing both further mech 2 and further stats 2? Because that's more than you need to do. But yeah, like I said, what about the fact you're doing further mech 2 and further stats 2? Oh, wow, new man. So how many hours of maths were you doing a week? How many hours of maths were you doing a week if you were doing all the modules? No. So sorry. Let's answer those. So further mech 2, further stats were just second year topics. Well, it depends. Your school might have labeled them that way, but there are the modules further mech 1. There is the module further mech 2. Inside that, there are recommendations for year 12, year 13. So the spec for example, further stats 1 does have recommendations for stuff you do in year 1. So for example, everything to do with the Poisson and the binomial is in year 1, and they recommend keeping the geometric and negative binomial until year 2, but they are still further stats 1. Yeah, AQA might have less choices. So you've probably got quite a bit that is relevant in everything that we're doing. That is absolutely bonkers though. If you just did all of them and then chose afterwards, I mean, I love the concept. I love it. It's just the number of hours of maths. Wow. That's, I mean, as a further maths teacher, that sounds ideal. That sounds beautiful. There's very few schools have the ability to do that. So absolutely kudos to you. All right. Yeah. Any more questions from you, gang? Any more questions from anyone? I think a lot of people have moseyed on off. We told you we'd be keeping you until 6:15. You can always reach out to the admin team on myheadspace.co.uk or .com with any of your questions. They'll be able to help you out and answer. Mostly the questions come through to me, so I'll be able to answer any of those. All right. All right, brilliant. Well, I hope you enjoyed this evening. Just a nice little bit of De Moivre theorem and complex numbers, complete with computer non-compliance. Always a glorious thing. Have a lovely evening, everyone. Have a lovely, lovely evening. And hopefully I will see you on Sunday where we get to hang out. All right. And again, any other questions, just put it through our team on the website. Have a lovely, lovely evening. Toodle bye.